today's lesson is about the pressure gradient force, and we're going to look at more deeper into what is isobars and how it is measured. So the pressure gradient force. Wind is generated by variations of air pressure from one location to another, and isobars illustrate the air pressure on a map. In some regions the isobars are closely spaced, while in others they are more widely separated. The rate of change in air pressure over a horizontal distance measured from high to low pressure is known as the pressure gradient. At any specific point, the pressure gradient is perpendicular to the isobars. So, in simple terms, the pressure gradient force is the natural force that pushes air from areas of high atmospheric pressure to areas of low atmospheric pressure. And that is what causes the winds. So, to explain this further, imagine you have two balloons. The one balloon is really full of air, that's like the high pressure, and another balloon that you have is half empty, which is like a low pressure system. And if you connect them with a little tube, what will happen? So the air from the full balloon will rush very fast to the half empty balloon until they are both equally full. So your pressure gradient force is simply that rush of air. It's the natural push that makes air move from where there's a lot of pressure to where there's less pressure. The bigger the difference in pressure, the harder and faster that rush or force will be. So the HPA measures air pressure, so that numbers you see on the map is called the HPA, while the isobars, all the lines that you see here on a map, indicate areas of equal pressure and wind speed determined by their spacing. So let's connect our invisible air blanket, the HPA numbers, and the isobar lines to how fast wind blows, which we measure in kilometers per hour. So remember, your HPA, the numbers that you see on the isobar lines, it tells us how hard the air blanket is pressing down. Isobars are the lines on the weather map that connects places with the same HPA number. Now imagine those lines on your weather map. Isobars are like the lines on a highway for wind. So the wind wants to move from places where the air blanket is pushing harder, your higher HPA, to places where it's pushing less hard, your lower HPA. So if you look at this image here, when your isobars are further apart from each other, so think of it like wide empty highway lanes, the air doesn't feel a big rush to move. This means the wind will be slow, maybe a gentle breeze that you can hardly feel. If you look at this one, you'll see the spacings is closer together. So the isobars are closer together. Now imagine those highway lanes are suddenly squashed very close to each other. The air gets squeezed and has to rush much faster to get from one pressure to another. And this means the wind will be fast and strong. So just by looking at how close the isobar lines are on a weather map, we can tell if the wind will be a gentle breeze or a strong rushing wind. Right, so let's look at isobars in a low pressure gradient. So, in this diagram, The dotted red lines are the isobars, and they show the pressure in hectopascal, HPA. On the left, you have 1034 HPA, which shows a high pressure, and on the right, you have a lower pressure. And the distance, the image shows the pressure changes happening over a distance of 500 kilometers. So the pressure gradient, the isobar lines, as you can see, is not close to each other, which tells us something about the pressure gradient. The isobar lines that you see are spread out over a large distance of 500 kilometers. This means the pressure change from high to low is happening very gradually across that distance. So what happens, or what about the wind speed? So because the isobars are relatively far apart, indicating a low pressure gradient, and the wind speeds will be slow. So the average speed will be around 10 to 20 kilometers per hour. But it shows that the conditions would lead to low wind speeds. If these lines were much closer together over the same distance, then the wind would have been much faster. And that you will see in the next image. So in your high pressure gradient, so on the left, you have a high pressure starting at 1012 HPA, and as you move to the right, the pressure drops quickly, and it finally ends at 988 HPA on the low pressure side, and it's happening over the same distance of 500 kilometers, and the isobars, these red lines, are much closer together compared to the previous one. So when the isobars are close together, it means there is a steep pressure gradient. Think of it like a very steep hill for the air to roll down. So the high pressure gradient results in higher wind speeds and shows fast movement of air. And the wind speed, so because the isobars are very closely packed together, it indicates a high pressure gradient, and the wind speed will be very fast, and also strong winds. And you would expect winds in a range of, in this image, in the range of 30 to 60 kilometers per hour, or maybe more. So depending on the specific conditions and also the latitude, it's the kind of pressure pattern that would bring windy and stormy weather.